Every aspect of nature has been studied by humanity in an effort to better understand its place in the world. Nowadays, we are exploring new planets and stars every day, discovering new exotic objects, and the more we study the cosmos, the more we realize there is still much to learn. Whether we like it or not, this is the true purpose of science, as even on Earth, strange things occasionally occur. On the scientific front, however, on June 6, 1961, the Earth began to vibrate with a period of approximately 26 seconds. This was noticed by long-period seismographs all over the world, and it caught the attention of the scientific community when Jack Oliver, a geologist best known for his later work on tectonic plates, wrote a paper to try to explain the unusual event. If Greg Benson had not discovered it again in 2005, Oliver would not have discovered that this pulse was emanating from somewhere in the southern or equatorial Atlantic Ocean and that it was stronger during the winter in the southern hemisphere. Keep watching the video to learn more about this odd recurring phenomenon that has scientists baffled. Nobody is sure why the Earth is shaking every 26 seconds. What we know about it since Jack Oliver's research, numerous studies have been made to try to explain these odd Earth vibrations. This is what we know about it. First, more precisely, studies indicate that it shakes once every 26 seconds. Jack Oliver's 1960 results indicate a measure time of 27 seconds between each pulse, although better measurements were possible thanks to modern technology. As Jack Oliver suggested in his early work, these vibrations are caused by micro-earthquakes, and in 2006, scientists narrowed the range to the Gulf of Guinea in Western Africa. Seismic sensors are used to record these oscillations of the Earth. This pulse could be compared to a heartbeat, and it seems to be quite stable, not very different from one observation to the next. Observing the signal over the course of a year from the northern hemisphere, you would see it becoming stronger during summer and weaker during winter, which means that at the seismic point, which is supposed to be located in the southern hemisphere, the oscillations are most intense during winter. If you were a scientist, you would see something that looks like this appearing every 26 seconds in your data. Seismic activity. We claimed that the seismic origin of this pulse. Yet, what precisely is a seismic event? Consider liking the video and possibly subscribing to the channel before learning the solution to this query. Doing so would help us continue to bring you fresh, amazing discoveries each day. The term seismic event refers to occurrences that release energy in the Earth's crust, causing a series of seismic waves. These waves can be felt as an earthquake, or they may be so faint that they can only be detected with sophisticated technology. There are several causes of seismic activity, including human activity. Both volcanic activity and geological activity seismologists closely monitor seismic activity, and there are monitoring stations all over the world that are used to keep track of it. In some cases, a series of minor seismic events can precede a major event, giving a forewarning of what is to come. This can be used to prepare for foreign eventualities, such as evaluating people before a volcanic eruption. Seismometers are incredibly sensitive instruments used to record movement in the Earth's crust, enabling scientists to follow the path of seismic waves and pinpoint the source of seismic activity. The information gathered from these instruments is subsequently transmitted to a central monitoring station. Allowing data to be combined in order to identify any significant trends. Understanding the nature of seismic events can help seismologists and other researchers earn valuable money and can help to protect people in the area. Seismic events have a significant impact on the Earth, and monitoring seismic activity can provide important information about the safety of the areas nearby. Noise all around us. Though this particular pulse is intriguing, it is old news that the Earth constantly vibrates at a low frequency that is not associated with an earthquake or volcanic eruption. Scientists use this seismic noise to study the Earth's structure, and believe it or not, the Sun is the source of this quiet noise. But how? Here's how the sun heats the Earth more intensely near the equator than at the poles, creating storms, waves, and currents in the ocean. Similar to how tapping on a desk causes the other end to vibrate, energy is transferred to the Earth when these waves strike a coastline. When this interesting pulse was found in 2005, it startled scientists since they can use patterns and seismic noise to investigate the innards of the Earth. Seismologists like Michael Ritz-Waller said that these pulses are caused by the sun's energy transferring through the Earth's tectonic blades, causing seismic disturbance that is audible on the opposite side of the planet. In order to learn more about the origin of this pulse and what it can reveal about the Earth's innards, scientists are currently examining its source and the environment it is in. The source of the pulse. Given its origin, our peculiar pulse is most likely identical to all other sources of seismic noise. Garrett Euler, a scientist at Washington University, attempted to provide an explanation for the origin of the 26-second observed signal. He managed to constrain the location of the seismic micro-event to be somewhere around the Gulf of Guinea, and he claimed that the pulse is generated by waves hitting the coast in a specific way when these waves cross the oceans. As Ritz-Waller stated, the pressure difference in water doesn't have a significant impact on the ocean, but if the continental shelf was struck, it would deform the ocean floor just like if you were tapped on your desk. It would deform the area near your knuckle before being transmitted across the entire table. If the person hitting at the opposite side of the table places their hand or possibly their cheek on the table, they can feel the vibration, but this might not be noticeable. A group from Wuhan's Institute of Geodesy and Geophysics, led by Ing Jizia China, suggests that volcanoes, not waves, are the most likely source of the 26-second pulse. This is due to the fact that the pulse's origin point is suspiciously close to a volcano on the island of Sao Tome in the Bight of Bani. In fact, there is at least one other location on Earth where a volcano does cause a microsystem with some similarities to this one, and that is the Aso volcano in Japan. Japan is one of the most volcanically active nations in the world because the island nation is situated on the so-called Ring of Fire, where several planets experience earthquakes, and the deadliest volcanic eruption in Japan in nearly 9 decades occurred in 2014 on Mount Ontake in the central Nagano prefecture, killing 63 people. However, the debate is still ongoing, and we will likely need additional research to determine the true source of our strange signal. Even outside of this main controversy, more questions remain, such as why this microseismic event occurs in the Gulf of Guinea specifically. I mean, as far as we know, there are many other continental shelves and volcanoes in the world that aren't responsible for seismic pulses. What makes the Gulf of Guinea so unique? Unfortunately, we don't know. The hunt for answers continues, and each new finding advances our knowledge of the planet and the universe. It's possible that we'll find a special local characteristic that causes the pulse, or perhaps there's some type of connection between the local geography and solar radiation. Conclusions. To sum up, this enigmatic signal was discovered by geologist Jack Oliver in 1961 and then by Greg Benson in 2005. It is a seismic occurrence that occurs every 26 seconds and releases energy from the Earth's crust in the form of seismic waves. Since then, researchers have focused their attention on the Gulf of Guinea in Western Africa, and they now believe that wind, storms, ocean waves, and currents that shift energy to the land when they reach a coastline are to blame. This is comparable to what occurs when a desktop is touched, creating vibration on the opposite end. Moreover, the signal is stronger during the winter months in the southern hemisphere. There is disagreement regarding the cause of this pulse, with some believing it to be caused by wave activity. It may be volcanic in origin, according to some, but regardless, this occurrence serves as a reminder of just how much of the cosmos has to be explored and understood. Isn't that amazing? As you can see, studying natural phenomena frequently involves a variety of scientific disciplines, including geologists, seismologists, oceanographers, volcanologists, and others. Despite scientific progress, many natural occurrences are still mysterious, and it's possible that future discoveries will shed light on the cosmos mysteries. The strange signal is an intriguing illustration of the many mysteries surrounding our solar system and the cosmos. What do you think about this phenomenon and whether we will ever be able to grasp its cause? Let us know in the comments section below and have a nice day.